Good evening everyone. Today we will be discussing about KNN, that is nearest neighbor classifier. Okay. So what happens is that in the K nearest neighbor a very simple approach is taken. For example, suppose we have our X data set. Okay, like this. This is the point for feature 1. This is the point for the feature 2. Okay, these are feature 1, these are our independent feature 2. Now what happens, let me take one X test. I put some random X value new point in my data. So what will happen during the prediction, the distance will be calculated from each of the point which is present in our data set. Then the distances are sorted and we get the k nearest neighbor of our particular data point. And then what happens, that we take the average of the k nearest neighbor value. Suppose I take k is equal to 3, then I will find the k nearest neighbor, 3 nearest neighbor for this data point, and whatever will be their label, I will choose the average and do the classification that my particular x new data point belongs to this particular class. Okay, so you must have understood the concept on what it is based. But let me tell you some of the limitations also. Like, what are the limitations for this? The first one is the large data set. When we have a large data set, we should not use the KNN for classification. And let me tell you the reason. For example, we have a large data set, then what will happen? When we will come in the prediction process, our data point here it is present. And then what will happen is the distance from each of the point will be calculated. Suppose we have small data set, then we can calculate the distances. But if we have large data set, we will first calculate the distances from all the points which are very big in number. Then we will sort them, then we will pick the first k short distances from them. So what will happen is that it will be a very hectic and very time taking process. So that's why it is not preferred for the large data sets. And the second one is the outliers. Now suppose here is my f1, here is my f2, so it is clearly separate. Then suppose I have some 3 points here and they again belongs to this f1 only. So what will happen if my x test lie in this, suppose my new random x test come here, then it may assume that it is feature 1, but it is wrong, it should belong to feature 2. So in the data sets where some outliers are present, our prediction may be wrong. So in the case of the outliers also, our k-neighbor classifier fails. The third is the non-homogeneous scale. Like, suppose we have feature 1 and feature 2, and the feature 1 is having values between 1 to 10 while the feature 2 is having values between 0 to 1. So in such cases where the scaling of the data varies, in such cases also my KNN fails, that is in the non-homogeneous scales. Non-homogeneous scales. Okay. And the condition where again my data set, my KNN fails, is that inferencing. Now first let me tell you what do we mean by inferencing. Inferencing means telling what is the importance of a particular feature in detecting its class. Like, suppose here I have my feature 1 and feature 2, and a new test data, that is x, came. Then according to the nearest neighbor it will be classified to a particular class, but I will not get information that how much important was the feature 1 on deciding its class, or how much important is the feature 2 on deciding its class. So I do not get any inferencing, I just get my prediction. Okay, so this is the basic concept and working of my KNN model or algorithm in the supervised learning, and the limitations where we cannot use them. Thank you.